Right, so we're looking at log laws. These come up a lot, so we're off the air. Make sure we're following along here. These do come up all the time. They're going to rear their head over and over again as we progress through the methods course. They're used as an inverse of an exponential. So if I want to attack an unknown pair, and again I shouldn't see anyone's eyes anywhere but up here. You don't have to do anything, you don't have to write anything, you just got to listen along. They're used as a way of manipulating or undoing an exponential. So a log is like a square root is to a square. So a log to an exponential is like a square root to a square. So we use them to cancel out exponentials. Does that make sense? Just like we use minuses to get rid of pluses, they're opposite operations. We can think of them like that. So a few log laws that make these two make a lot of sense. Anything to the power of 0 is 1. So log of 1 must equal, because that's, if we take that out of log form, that's like saying a to the power of 0 equals 1. That's exactly the same thing. We know that. Happy with that? Anything to the power of 0 is 1, so therefore log a of 1 is equal to 0. Log a of a, which is like saying a to the power of what gives us a. A to the power of 1 gives us a. So those two laws are explained in that way. The next law is the one that I think comes up the most, and I call it the plug law. I don't know what they all call it, but I call it the plug law. I usually represent this with a P, not an M. And the reason I call it the plug law is because you plonk the power out the front. Okay, so if I've got anything to the power of, say, 3 or 4, let's say it was 3. If I had a to the power of 3, that would be 3 times log A. Doesn't matter what my base is. Cool? That's called the plug law. That comes up a heap. You'll never guess what this is called. Log. So you reckon they're going to call it the log plus law? Log addition law, and that just means if we've got two logs with the same base added together, we can simplify them by multiplying the two values inside. Cool? So if addition gives us multiplication, what do you think subtraction is going to give us?
Divide.
Division. And the last one is the change of base law. So if I've got log base AB and log base divided by log base AC, I can represent that as log base CB. The two most common bases with our logs are log base 10 and log base E. Remember how I put E on the board yesterday and said it's a special number? So if you see this, that would mean log base 10, 6. So if you type in your calculator log 6, that'll assume log base 10. How can you check that? Change this number from 6 to something else.
8.
2.
26.
Thank you, Max. Log 10, which would equal what?
1.
So if you put log 10 in your calculator and it equals 1, that tells you. Is it? The math checks out. The other one that we often see if we can prove that ln is log base E. Make sure it works on your calculator. Yep, so put e to the power of.
What does E? What's E equal to?
2 points, like pi, so 2.73 whatever. But yours number. But if you put ln e to the power of 1, what do you get? There's a button ln, it's next to log. Natural log. Log base E.
It's 1.
What button is log? Do you get an E button? Or do we get
Yeah, there's an E button on there.
Where's the E button?
Look,
I don't know.
before we use our mouth, let's use our
I see
eyes.
an E squared, but I don't see
Hit EX, hit that button, shift EX. And then make it power of 1.
Because I hate getting
What's E, isn't it? Okay? Good. So we're going to look at some of the questions that we're asked to do here, and this one is converting to log form. Not a particularly great question, but I do like that it allows us to engage with a few of our newly learnt log laws. So here we've got 5 to the power of negative 2 equals 1 on 25, which we know it does. So it's not asking us to solve, it's just asking us to change the form. So to do that, I obviously want to attack the exponential or remove the exponential power, the power. So to do that, I apply a log to both sides. It does not matter what base I choose. What base have I chosen by not writing a base?
10.
Log base 10. I then use what law have I used here in the second line? The plug law. I've plugged my power at the front. I've then divided both sides by log 5. What law have I used here?
The subtraction. The base.
Change of base law. I had log 10 1 on 25 divided by log 10 5. My new base has become my 5, which is what we had before on the tiny part of the board because I ran out of room. Sweet? So that's what I like about that question. You don't have to go through every step every time, but it's just about showing us that we can use our manipulation very quickly. Sweet?
Yeah.
And then you've gone to question 3, 5, 1, 2, 3, 4, 1, 2, 3, 5, 6, 7,